Uh, what was the last topic? What was the last topic? Please tell.
Sir, it was parallel
This one?
combination of resistance.
Okay, very good. So parallel combination of resistance we have completed,
Yes, sir.
and we have solved one question also.
Yes, sir.
Yeah. So in parallel combination, the resultant resistance is given by this formula. We have discussed this formula.
Yes, sir.
Yeah. Now we will take one question on the mixed combination, and this is very not a very but quite good question, I will say. So the question is my voice is okay na?
Yes, sir. Yes, sir.
So the question is, we have a resistance of 5 ohm here. Okay.
Yes, sir.
And 220 ohm resistances are there like this. Two 20 ohm resistances are like this, and this is 5 ohm resistance, and this is 20 ohm. This is 20, and I am considering this as R1, this as R2, this as R3, and we have to find first of all the equivalent resistance.
Yes, sir.
First of all, we will calculate the equivalent resistance of this circuit, of this whole combination. We will calculate the equivalent resistance, and another is we will find the voltages and the current across each resistance, So this time we will see this is a mixed combination. Here is a parallel combination and series combination. We will calculate the equivalent resistance, and after that we will calculate the voltage and the current across each resistance. So this is our question. So I am calculating first the equivalent resistance. So please tell me, this 20 ohm resistance and this 20 ohm resistance is connected end to end.
Yes, sir.
So which side? Very good.
Parallel, sir.
Very good. So for parallel combination, we can find the equivalent of this.
Yes,
we can
sir.
find the equivalent of this. So equivalent of R23, I am finding R23. So I have told you for two resistances that are connected in parallel combination, we have formula R1 R2 divided by R, means first you will multiply those resistances and divide it by this. Add means
yes,
you will write R2 into R3 divided by R2 plus R3.
R3. Yes, sir.
So this will become 20 into 20 divided by 20 plus 20. This will become 20 into 20 divided by 40. When you will calculate this, you will get 10 ohm. So now see this. We have just calculated the equivalent of these two resistances. Now I am just modifying this circuit. Just do the question as I am doing. So
Yes,
what I
sir.
am now, instead of these two resistors, we will connect only one resistance of 10 ohm in series with this 5 ohm resistor. So now let's see. So instead of two 20 ohm resistances, I am just connecting a 10 ohm resistance, and I am giving the name is R23.
Yes, sir.
Now we have changed our circuit, and
Yes.
now they are saying a battery of 100 volt also connected to the circuit, a battery of 100 volt. Here the 100 volt battery is connected.
Yes, sir.
So Harsh, from this circuit we can say the current is flowing like this.
Yes, sir.
Current is flowing like this, and from this the current will divide now.
Yes.
From here the current will divide.
Yes, sir.
Means in this branch there will be a current I3. In this branch there will be a current. There will be a current I2. Here the current will be I3. So I am just giving you the idea. And this 100 volt will be divided equally between the 5 ohm and equivalent of this. Means now we have this circuit. Now we have this circuit. So what we will do, so now this 10 ohm and 5 ohm are in series. So you
Yes,
can
sir.
write R1 and
R2 are in series. 2, 3 are in
R2
series.
series. So can we find the equivalent, means R1, 2, 3?
Yes, sir.
R1
R1
plus.
plus R2, 3.
So this will become 5 plus 10,
Yes, sir.
15 ohm.
15.
So 15 ohm. So overall resistance of the circuit is 15 ohm. If now I want to calculate this current, means this is the total current now.
Yes, sir.
This is the total current I, capital I. So I is equal to total voltage divided by the equivalent resistance,
Yes, sir.
and total voltage is 100
Yes, sir.
and equivalent resistance is 50. So when you will divide this both sides, numerator and denominator, by 5, then you will get 20 divided by 3, not ampere, 20 divided by 3 ampere. So value of this current is 20 by 3 ampere. So here also the current will be same.
Yes.
So in 5 ohm resistance, the current is 20 by 3 ampere. So we have to find the current and the voltage across each resistance. So first I am starting with R1. So 4, I am writing 4 R1. Current is I1, and voltage I am supposing here is V1. So here the current is I1 I am supposing,
Yes, sir.
and voltage is V1. So I1 is equal to I now here. I1 is equal to I,
Yes.
because this is connected in the series combination. I1 is equal to I, and that is equal to 20 by 3 ampere. If I want to calculate V1, means voltage across the resistance R1, then I will write I1 into R1. Value of I1 is 20 by 3 and R1 is 5.
Yes,
So this
sir.
will become 100 divided by. So we have V1. We have this V1 as equal to 100 divided by 3. Means voltage across this 5 ohm resistance. Voltage across this 5 ohm resistance is 100 by 3.
100 was.
Now we will calculate the voltage across this V23 means voltage across this 10 ohm resistance.
Yes, sir.
So can I write this like from here? Can I write this V1 plus V23 is equal to 100? Means
Yes.
you can see that this voltage, the voltage across this plus voltage across this equal to the total voltage.
Yes, sir.
Yeah. So V1, we have the value of V1 as 100 by 3 plus we have to find V23 that is equal to 100. So we can find here, we can find from here this 100 minus 100 by 3, take the LCM. Now take the LCM 3, you will get here 300 minus 100. You will get this as 200 divided by 3. What is the unit of voltage? Volts.
Volt.
Volts. So we have V23.
Yes.
V23 as equal to 200 divided by 3 volt. So now what is up? Now we have to see, we have just replaced this. We will in what is in actual we have this now.
Yes, sir.
In actual we have this. So I am just copying this and pasting here. Means just understand the concept. What I want to tell you that means this 20 ohm resistance, 220 ohm resistances are, you can suppose, have the voltage of this 200 divided by 3, 200 divided by 3 volts, and this is equivalent to this 10 ohm. So this 10 ohm also have the voltage 200 by 3, and we have to find the voltage across this R3 and R2. So this is a parallel combination, Harsh. See, this is the
Yes, sir.
parallel
Parallel combination.
combination.
Yes,
So
sir.
you can write R2 and R3 are connected in parallel, and we know that in parallel combination the voltage V2 is equal to V3 is equal to the voltage of the total voltage. So across the resistance R2, across the resistance R3, the voltage is this. Now we want to find the current. Now calculate the current. What will be the current here? Current. Now calculate the total current of here. Means you can say, you can find the current here. No? I is equal to V divided by R. Just do it with some another way. I am just telling you with the easiest way. See here. Here the current is going in this R23, means R23 is this circuit now. R23 is this circuit now, and in this circuit the current is going as 20 by 3 ampere.
Yes, sir.
The current is going 20 by 3 ampere current is going, and if you want to find I2, here the current I2 is going, here the current I1 is going. So if you want to find I2, you will have V2 divided by R2.
R2.
So V2 is 200 divided by 3 and R2 is
Yes,
20.
Sir. Yes, sir.
So when you will calculate this, you will get
20.
20 by 6, or further you will solve it, you will get 10 by 3 ampere. When you will solve for I3, then you will write V3 divided by R3. Then V3 is again 200 by 3, and this is again 20. Then again you will get 20 by 6, and you will get 10 by 3
Yes, sir.
ampere current. So we have calculated all the parameters, all the things. We have calculated the current through this resistance R1, voltage through this resistance, and we have calculated the current through this resistance and voltage through this resistance, and
Yes, sir.
current through this resistance and voltage through this resistance, and also we have calculated the equivalent resistance
Yes, sir.
of the circuit. So this is the equivalent resistance of the circuit. This is the part first, and from here the part second, answer of this part second. So now you can note it down. I'm just zooming it out. Okay, Harsh. And
Yes,
if you
sir.
have any doubt, you can ask me.
Sir, you can scroll to part 2, sir.
Part 2, na?
Yeah.
Okay.
Sir, more down, sir.
More down.
Yeah. Yeah, that's it. Thank you.
So have you got this now? How I have solved the question?
Yes, sir. Yes, sir.
So one by one, step by step, you have to follow. Step by step, you have to solve the circuit. Otherwise, you will get confused. Harsh, can you now solve these kinds of questions?
Yes, sir.
Okay. You have to just apply the formulas, and you have to see the which combination is parallel or which combination is series. You have to identify. Means
Yes, sir.
these resistances are connected end to end, so you can say this is a parallel combination. In series combination, the current is same. In parallel combination, the potential difference or the voltage is same.
Yes, sir.
Yeah.
So done, sir.
Okay, fine. So now we are just moving to the next step. Means we will solve some better question now. There are types of question now that we cannot easily identify this type of combination is this. Okay, so you can write on calculating equivalent. Harsh, is your internet connection is okay?
Yes, sir. It's okay, sir.
I'm checking mine. My voice and all things are video and all things are okay na?
Yes, sir.
Just I'm checking what is speed is I'm getting. Very nice. Okay, that is fine. So my connection is okay. So questions on calculating equivalent resistance. These kinds of questions we will solve. Earlier, I have told you if a combination is like this, means resistances are connected like this.
Yes, sir.
This thing is resistance. This thing is
Series.
resistance. This is known as the series combination, and also the current is same here. We have already discussed this.
Yes, sir.
And if we have a connection like this, resistances are connected end to end, means one end of this resistance is connected to another end of the resistance,
Parallel.
then the combination is
Parallel.
parallel. End to end connection is parallel.
Yes,
And in
sir.
parallel combination, the potential difference across each resistance is same.
Yes, sir.
Here also the V, here also V, here also V. The potential difference will remain same. So no need to write this. We already knew this. So now I am giving you one question. We will solve that, and that question is quite good. Actually, we are having a wiring. This is a wire, na?
Yes, sir.
Yeah. This white color is the wire, and what I have done, I have connected one resistance here on this wire, one resistance here on this wire, one resistance here on this wire, one resistance here on this wire. This is the wire. I have connected one resistance here, one resistance here, one resistance here. Now I have connected one resistance here also, one resistance here also, and this is point A, B, C, D,
Yes,
C
sir.
and D, and all the resistances have the value R. All resistances are equal, and we have to find the equivalent resistance between points A and C, between points A and C. Number one, between point A and C. Second, between point A and D. Between point A and D. Do the same thing that I am doing. Do the same thing that I am doing for solving. Now you cannot identify this combination. Which type of combination is this? This is neither the series nor the parallel combination.
Yes, sir. We have to change the diagram, sir.
Yeah, actually, there are the things here. There are some resistances here connected in pair series, and then we will make the equivalent, and after that we will get another kind of combination. So now, what should you do? We will change the diagram also, but we will do one more thing. Now, we are calculating the equivalent resistance between point this A point and between point C point. So
Yes,
connect this point with a imaginary battery, or cell. Why I am doing this, you will get into it. Connect a cell between A and C. We want to calculate the equivalent resistance between point A and C. Then we will connect a imaginary cell between point A and C. This is a cell. So why we are doing this? Let's see. Now I can remove this point. I can remove this point also. I have just written the point. Now, Harsh, she. This is the single wire now.
Yes, sir.
And I have told you on a single wire, resistances are connected in series.
Series, yes, sir.
And this again also a single wire. There is no branching here.
Yes, sir.
This means this resistance means I am supposing this resistance as 1, this as 2, this as 3, this as 4, this as 5. So you can say resistance 3 and 4. Why resistance 3 and 4 are connected in series? Because They are connected on the same wire. You can see here.
Yes, sir. Same wiring.
I am just giving you a demo. You have this wire now. You have this wire.
Yes,
and
sir.
you have connected on this wire two resistances.
Yes, sir.
And now you fold this wire like this. So wire is same, or
Same.
and the combination will also remain same, na? If you
Same,
fold
yes,
the
sir.
wire,
There is no
fold,
branching, sir. Yes.
means the combination will change when there will be the branching, but the branch, there is no branching. So you can say 3 and 4 connected in parallel. Sorry, not parallel. 3 and 4 are connected in series.
Yes, sir. Series.
So you can find R34, mean equivalent of R3 plus R4, that is R plus R, it will become 2R. Have you got this? Means
Yes, sir.
I have calculated the equivalent of these two resistances. So this is 2R. So now see, this resistance 1 and 2 also connected in series.
Yes, sir.
Also connected in series. So you can find R12, R1 plus R2.
Yes, sir.
So this is R plus R. This will become 2R. Okay.
Yes, sir.
This will become 2R. So now we will just change the circuit again. Instead of these two resistance, we will use one equivalent resistance of 2R.
Yes, sir.
We have connected this with a battery like this. Like this we have connected. And I am just changing this. Okay. I am just changing this. Now I am replacing these resistances with a single resistance connect on the wire.
Yes, sir.
So that single resistance will become now 2R. Equivalent resistance is 2R now.
Yes, sir.
So this is 2R because I have written this because we have calculated this here now.
Yes,
And
sir.
this resistance 2R named as R34. So this is, I am naming it R34. So also I will do the same thing for the lower part. See this. Step by step we will solve. So a resistance of 2R and this resistance is named as R12. Now you have to identify. See the point A and B. All the resistances are connected end to end or not?
Yes, sir.
So which combination will all resistance are in?
Series.
No, beta, parallel.
No, parallel, yeah. End to end branching.
I have told you, na.
Yeah, sorry.
End to end connection means parallel. See, this resistance 2R is connected end to end, and one end of this 2R is at A, one end of this R is at A, one end of this 2R is at A, and same is the case with this.
Yes, sir.
So you can say R34 and R5. This is R5. 5 means R5.
Yes, sir.
And 2R.
Yes, sir. Are in parallel.
2R are in parallel. And we can find the equivalent of the parallel combination.
Yes, sir.
1 upon divided by
1 by R is equal to 1 by R3, 4 plus 1 by R5 plus
2R. This is R12.
Yes, sir.
So you can 1 by 2R, 1 by R plus 1 by 2R. You can calculate this. Okay, no problem. Just wait. 1, 2, 3, 4, and 5. This is the equivalent resistance. So this is 1 upon 2R plus 1 upon R plus 1 upon 2R. See here, I have written this 1 upon 2R because this is a parallel combination, 1 by R, 1 by 2R. So take the LCM. What is the LCM of this? 2R is the LCM.
2R, sir.
So here is 1, here is 2, here is 1. This will become 4 divided by 2R.
2R.
Then when you will calculate R 1, 2, 3, 4, 5 means the equivalent resistance of circuit, then you will receive the reciprocal of this, you will get 2 by 4 into R, this will become R by 2. So the equivalent resistance of the circuit is equivalent resistance of the circuit means resistance. Yeah, R by 2 will get the
yeah, resistance of 1, 2, 3, 4, and 5.
Or you can simply replace this with this. Means R between point A and C, na? We have calculated
yes, sir.
point A and
yes,
C.
Sir.
So we can write it like this. So this is the point A and C. Okay, this is R A C, na? So the answer is R by 2. So first
Yes,
part
sir.
we have completed. Now in the same way we will calculate the resistance in between the point A and D. In between the point A and D. So second part of the question now I am solving. Same way we will solve the second part of. Same way. This time, answer second, we have to find the resistance between the point A and D. So what we will do, we will just connect the imaginary cell between point A and D.
Yes, sir.
Imaginary cell between point A and D. Now, other points we can remove. Point B we can remove. Point C we can remove. Now, see here that this this is a single wire now, na?
Yes, sir.
So I am giving a name. This is resistance 1. This is 2.
Yes, sir.
This is 3. This is 4. And this is 5. So this is a single wire.
Yes, sir.
This is a single wire. Means 3 and 4 are connected in?
3 and 4 are connected in series, sir.
Yeah. 3 and 4 are connected in series. So we can find R34. We can find R34. R34 we can find. So this will become R3 plus R4. And the value of R3 is R. And this is again R. This will become 2R. Now, instead of these two resistances, we will just connect a resistance of 2R ohm. I am just modifying this circuit again. So I am just connecting a single resistance in between. Identification is very, very important. You have to identify the resistances are connected by end to end, or so now Harsh, you can see this end and this end. Yes, this is resistance 2R and I am giving it a name R34.
Yes, sir.
So see this 2R and this R are connected end to end. So you can say this resistance R and 2R are connected in parallel.
Yes, sir.
So you can write here R34 and this is R5.
R5.
Yeah. R5 are in parallel.
And sir, R12 is also in parallel, right?
No, we cannot see that. We cannot say that because here is a point, so current will divide. So we cannot identify the combination right now. Okay. We cannot, yeah. But after the equivalence of these two resistance, maybe we can find.
Yes, sir.
So just you have to, I am just saying that you have to solve the question step by step. You cannot add all the resistance at one time, because there are the complexity in the circuit. So here, see here, this resistance R, this two R are connected in parallel because they are connected end to end. But we cannot say that this R and this R are connected in parallel or series. We do not have any idea. So just go step by step. So can we find R 345
Yes, sir.
connected in parallel? Means
Yes, sir.
first multiply this
2R
to,
plus
no no
1
no
by R.
no, that is fine, but when two resistance connected in parallel, so how we will calculate? First multiply the two resistances, 2R into R,
Yeah, it's 2 resistance.
and
Yeah, so 2R plus R.
yeah, this you should know na.
Yeah.
This will save your time in your examination. This is 3R. Now R and R cancel, you will get the answer 2R divided
2R
by 3.
3.
So now what we will do? We will just remove this resistance and remove this resistance and connect a resistance of 2R by 3. Step by step we will solve, and after that we will see which resistance is connected in parallel and in series. We will get that, but step by step we have to solve. Now instead I am just removing this resistance, because, and also I am just removing this R5 because we have calculated the equivalent. So now I can connect this with the help of a single resistance of 2 by 3 ohm,
Yes, sir.
2 by 3 R, 2 by 3, 2R by 3 resistance. And now, and I am giving it a name R345. So now see here, this is a single wire now, no
Yes, sir.
branching,
Yes, sir.
single wire. So what you can say, R345 and R2 are connected in?
R345 and R2 are in parallel, sir.
No, no, not in parallel. Na? This is a single wire.
Oh, yeah.
On a single wire, if you connect the resistances, then this will be a series combination. Na?
Yeah, all of them will be in series, yes. If it's a single
No,
wire.
not all of
No,
them. No.
R2, 2, 3, 4, 5, and R.
I am saying just look at the resistances at a time. Okay. Just wait.
Yes, sir.
Okay, Harsh, let's start. So this wire is same now.
Yes, sir.
So I have told you, don't consider this right now. Right now, don't consider this. Step by step, we don't know this is connected with this right now, but we will first calculate the equivalent of this, then we will decide which combination will become it.
Yes, sir.
So this R345 and R2 series are in series because the same wire. So we can find R2, 3, 4, 5. In series, we will add the resistances 2 by 3R plus R. Take the LCM. What will the LCM of this? 3.
3.
This will become 2R. This will
2R
become
plus
3.
3. R.
Not 2. 2R plus 3R. This will become
3R,
3R.
sir.
Yeah. So this will become 5R divided
5R
by.
by 3.
So now we have calculated the equivalent resistance of this and this. Now I am removing this and this. I am just removing this and this. See here. I'm just removing this. Why I am removing this? Because we have just calculated the equivalent resistance. Huh?
Yes, sir.
So see this. Here I am just connecting a resistance of single resistance of 5R by 3. 5R by 3, and this resistance I will give the name R2, 3, 4, and 5. Now Harsh, see, now you can identify this end to end connection, na? This R
Yes,
and this 5R, 3R and connected end to end. So which kind of combination is this?
sir, it is parallel series.
Very good, very good. So I have modified the circuit. After this step we will modify now. So we can write this as 2R and 2R by 3 and R. This is 2R by 3 and this is R. This is 2R by 3 and this is R, and I have given it the name as 2, and this is the name as R345. This is named as R345. Now I have just modified the circuit again, and I
Yes,
can
sir.
say resistance 1 and resistance means you can say R1 and R2, 3, 4, 5 are connected in parallel combination.
Yes, sir.
So parallel combination. Can you find the resultant of this and this? Please try.
Yes, sir. I'll try.
By the same method, multiplication first and after that the addition.
Yes, sir.
So resultant will be R1, 2, 3, 4, 5. Just find and tell me the answer. I am waiting for the answer.
Sir, is it 5R by 8?
I'm just solving. You can check.
Yes, sir.
So multiply this R with 5 R by 3, and after
Yes,
that calculate R plus
R plus 5R by 3.
by 3. So now this will become 5 R square divided by
R square
3,
by 3.
and this
And it
will
will become
become
8R
5
by 3.
8. Very good. So when you will solve this, 5R square by 3 multiplication, this will become 3 by
3 by
8R.
8R. Yeah, 3 triple cancel.
So 3 and 3. So your answer is correct now? 5R
Yes,
divided
sir.
by 3.
5R by 8.
So the equivalent resistance means the equivalent resistance between point A and
Sir,
yeah,
sir,
A and
5R
D.
by 8, sir.
Oh,
Not
sorry,
3.
5R by 8. Okay, no problem.
Yes, sir.
We can just do this. So R, A, and D we have to find, and the answer is 5RY8. So in this way you can find now. See
Yes, sir.
how much time I have just modified the circuit. But with the help of practice, you can solve this question in 5 seconds also. But it will take time. So please note it down. Have you completed this from here now?
Yes, sir. From there.
From second part now?
Sir, just
Yeah.
after I'm writing the question, sir.
Okay,
Like,
this
I wrote
question.
the answer, but I'm writing the question.
Okay, okay, write the. Okay, okay, please write. You can write.
Sir, can you scroll down where you connected the cell between A and C?
Is that fine?
Yes, sir. Yes, sir.
Okay.
So can you scroll down?
Should I scroll down, Harsh?
Sir, just answer.
Okay. And make the diagram properly. Okay.
Yes, sir. Yes, sir.
Yeah. Otherwise, you will get confused.
Yes, sir. So can you scroll down?
Written, Harsh?
Sir, just a minute, I'm drawing the second diagram, sir.
Okay. Right, these resistances, no? I have represented resistances R34 and R345.
Yes, sir, I'm writing that. Yes, sir, I
Because
wrote that.
I have written this because you do not have the confusion while you revise your notes. Okay,
Yes, sir.
that's why I have written in this form.
Yes, sir.
So there are the steps in solving the questions. Means you have to solve the first part of the circuit, and after that you will improve the circuit, and after that you will solve another part of the circuit. Then again
Yes,
you
sir.
will improve the circuit, and this is the
Yes,
process
sir.
of solving.
Yes, sir. Can I scroll down, sir?
Yeah, this is the last. Okay. This is
Yes,
the
sir.
last. So after this, we will have very good question, and that we will solve without connecting the cell. Sorry.
Done, sir.
Okay, very good. Now I am having a very beautiful question. Beautiful in the sense of concept, I must say. Hmm. Yeah. Hmm. We have a wiring like this, circular type wiring. Okay. And this is our question, and mm, resistances are connected. Suppose here a resistance of 2 ohm. 2 ohm resistance is connected here.
Yes, sir.
And from this wire, another wire is connected, and resistances are connected like this. This 10 ohm resistance, and this is also a 10 ohm resistance connected. And here also a 5 ohm resistance is connected like this. And we are having 2 points here. We are having 2 points here. We have to calculate the equivalent resistance between these 2 points, that is A and B. So the question is, find the equivalent resistance. Find the equivalent resistance in between point A and B. Now, Okay. Now we will solve this question. Now see, this is a single wire.
Yes, sir.
On a single wire, two resistances are connected. So
Yes,
this
sir.
10 ohm and 10 ohm are connected in series.
Yes, sir. Series, sir.
So I am supposing this as a resistance 1, this as a resistance 2, this as a resistance 3, this as a resistance 4. So you can say 2 and 3 are in series. So we can find the equivalent resistance R23. So R23 is 10 plus 10.
Yes, sir.
This is 20 ohm. So now we will modify the circuit, means instead of this 10 ohm and 10 ohm resistance, we will connect a single 20 ohm resistance. We will connect a
single 20 ohm resistance.
So just removing this 10 ohm resistances, and I will connect here a single 20 ohm resistance. Because we have calculated the equivalent resistance, no? That is why we are doing this. So now this is not okay. The 20 ohm resistance we will connect, because we have just calculated the equivalent of this. So we will just modify the circuit. And so now Harsh, you can see here at this point, see this resistance 20 ohm resistance, I am giving it a name as R23. This 20 ohm resistance and 2 ohm resistance is connected in parallel.
20 ohm resistor, 2 ohm resistor is connected in
Parallel, because
parallel.
this is end to end connection, na?
Yes, sir.
So you will write R23 and R1 connected in parallel, because they are connected end to end. So can we find the equivalent R23 1 2 3? First, the multiplication of two resistances and 2 plus 20. So this will become 40 divided by 22. This will become 20 by 11 ohm. So again, we will modify this circuit. So we have just calculated the equivalent of this 20 ohm and 2 ohm. So I am just removing this 20 ohm and I am just connecting this a single resistance of 20 by 11 ohm. Single resistance of 20 by 11 ohm. 20 divided by 11 ohm resistance I am connecting here, and this resistance is connected with this 5 ohm resistance, and I am giving it 1 2 I'm giving it a name 1 2 3. Okay, 1 2 3 2 3. This is the name, and this is so. Harsh, can you tell me about this? Which combination of this resistance is with this resistance, as this is a single wire?
So series,
So,
sir.
series, very good, because two resistances are connected on a single wire. So
Yes,
current
sir.
is same, so means series combination. So you
Yes,
will
sir.
say R1 2 3 and R4 are connected in series.
Series.
So can we find the equivalent R1 2 3 4?
Yes, sir.
20 by 11 plus 5.
Yes, sir.
Take the LCM.
It will be 11, sir. LCM 55 by
Yeah, 11. It will become
70,
20
sir.
plus
77 by 11.
no. This will become 75 by 11. Na?
Oh, yeah, 75. Oh, sorry, 75
It
by
means
11.
that you can write this RAV, equivalent resistance between point A and B, is equal to 75 by 11, and unit of resistance is ohm. OHM ohm.
Yes, sir.
Actually, Ohm is the name of the scientist, Ohm's law.
Yes, sir.
So he has given the unit of resistance also. So 75 divided by 11 is the answer. So in this way, you can solve the questions. Now, just note it down
Sir, you can scroll down from the second part.
to the second part now. So this you have written now.
Yes, sir. I did till 20 ohm. Yeah. Okay, now.
This no?
Yeah. Now I have to do this, sir. Wait.
Okay, fine. Actually, I am just moving it up a little bit. Now it's fine.
So you can scroll down. Done, sir.
Now we have type second question. Now we have type second question, potential divider method. We will use potential divider method to identify the circuit. To identify the circuit combination. Potential divider method. So one thing more I want to tell you, if the resistances have the same potential difference, then they are connected in parallel. No?
If they have same potential difference, they
Potential
can
difference.
Yes, sir. They can in parallel, sir.
Resistances having same potential difference are connected in parallel. So suppose three resistances are connected like this. And these resistances are connecting with wire like this, and from here these two resistances are connected with wire. So Harsh, can you identify the type of combination here?
Yes, sir.
Can
The
you
type of combination.
means which type of combination is series combination, parallel combination, mixed combination?
Sir, can you
Mixed
name
means
the resistors, sir?
what? Can you leave the class?
No. Can you name the resistors? R1, R2, R3.
Means suppose this is R1.
Okay. Yeah.
And this is suppose R2. Suppose this is R3. Now, can you tell what kind of combination it is?
Sir, R1 and R3 are in series,
Okay.
and then R2
R2.
is parallel to them, sir.
Okay. 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 Let's see whether your answer is correct
Sir,
or
because we make Wheatstone's bridge and then do that.
fine. Just we will see it. No problem. We will see whether you are correct or not. So suppose I'm just removing this from here. Means- So you can name the resistance this as 1, this as a resistance 2, this as a resistance 3. You can name it. And we will see which type of combination is this. Right now we don't know anything, but we know certain things about the potential. We know certain things about the potential, and I have told you it in the capacitance also. In the when capacitors are connected in parallel and when resistances are connected in parallel, then also I have told you. Suppose this is a point A, the potential here is VA. Here also the potential is VA because
Yes, sir.
there is no resistance in the path. VA, VA, VA. And here the potential is VV, then here also the potential is VV. Here also the potential is VV. Here also the potential is VV. So here also the potential is VV. So now if you want to calculate the potential difference, means V1 is potential difference across R1, you will get VA minus VV. If you want to calculate potential difference across R2, you will get VV minus VA. You can write VA minus VV. Because VA minus VV and magnitude of VA minus VV or VV minus VA is same, so you can write this. V3 you will calculate potential difference across this, you will write VA minus VV. So see, all the resistances have the same potential difference. So we can
Yes, sir.
say that R1, R2, R3 are connected in parallel, na? Because I have told you if the potential difference across, I have written this line here, na?
Yes, sir. Yes, sir.
Resistance having same
Same
potential difference
potential
are
difference are
connected
connected
in,
in parallel.
yeah. So you can say R1, R2 and R3 have same potential difference, so we can say they are connected in parallel. So for parallel combination, R equivalent, you can write 1 upon R1 plus 1 upon
R2 plus 1
R2
upon
plus 1
R3.
upon R3, and all the resistances are equal. R1 is equal
Yes,
to
sir.
R, R2 is equal to R, R3 is equal to R. You will get 3 by R. When you will calculate the equivalent resistance, you will get R by 3 as your answer. This is
Yes,
3.
sir. Yes, sir.
So note it down. So
Yes, sir.
see, this was not looking like a parallel combination. We have Wheatstone bridge also. After the next topic, we have Wheatstone bridge. Then there is, you are right, 50% right. There is a question looking like this. A
Yes, sir.
Wheatstone
Because
bridge.
I did that question. It was similar.
Yeah, I
We
know
had a
that.
fourth resistor.
Actually, hey, there something is different there. Something is different there in the Wheatstone bridge case. There is
Yes, sir.
something. There is a little bit difference. So
Okay.
now you can just copy. We will solve that question also that you are talking about. But actually, in that question, I
Yes,
am
sir.
just telling you here one resistance is connected and here
Yeah,
also
yeah,
one
yeah.
resistance.
There was a fourth and fifth
Then
resistance.
then it will become the weighted stone bridge. So we will solve that question also, no problem. And please make the circuit properly. And why,
Yes, sir.
Harsh, please tell me one thing, why the potential on this wire is same? Because on if you are moving on this wire, there is no
Yes, sir.
resistance in the
Yeah,
path, then
yes,
the
sir.
potential remains same.
The same. Yes, sir. So can I scroll down a little bit?
Yeah.
Done, sir.
Now we have a type 3. mm, Not a type 3. I will just make a star and write this. If you have a resistance like this, resistance connected like this, and if you have connected this wire, and suppose the current is flowing, so all the current will flow through this path.
Yes, sir.
No current will go in the resistance. No current will go in the resistance.
Resistance.
So you can just remove this resistance from here. You can make this as a single wire, because in the circuit the existence of resistance, there is no existence of resistance without the current. If there is no current in the resistance, then we will remove from the circuit. And if you are connecting resistances like this now, then all the current will go through this path. No current will go through this path. So in both the resistances, there is no current.
Yes, sir.
So you can just remove this, and instead of this, you can make a single wire. So this is known as a short circuit.
Yes, sir.
Short circuit. And if there is a case, there is one more case. If two resistances are connected like this, and you have short circuited this resistances, but you have connected a wire. This is not the case of short circuit, because see here, the current is like this.
Yes, sir.
Current will go like this, and current will go like this, and current will go like this. No current in this, but
Yes.
this is another wire. From here the current will go to here and here. So means there is no short circuit. No short circuit means this resistance will come into the existence in case of the circuit analysis. So we have one question similar to the previous question, but I am adding little concept there of short circuiting. Suppose we have four resistances, and this is connected like this, and this is connected like this with a wire, and this resistance is connected with this, and this is point A and this is point B, and we have to find the equivalent resistance and this is R. All resistances have the same value, are equivalent. Equivalent resistance between A and B we have to find. Now,
Yes, sir.
now see this resistance. This resistance is short circuited.
Yes.
So we can remove this resistance and make it as a single wire.
Yes, sir.
Make it as a single wire as this has become B point. Now we have already solved this. This combination is parallel combination.
Yes, sir. Parallel R1, R2, R3 parallel.
Yeah. If this is 1, this is 2, this is 3. So you can say
1 by R.
1,
Yeah.
2, 3 are in parallel.
Parallel.
So you can find the R equivalent. 1 upon R equivalent is equal to
1 by R1 plus 1 by R2 plus 1 by R3.
Yeah, 1 by R, and that is equal to 3
3
by
by
R. And R equivalent you will get
R by 3.
Yeah.
Yes, sir.
So note it down. So this is something I have added here, a resistance which is short circuited by
Yes,
wiring.
sir.
So you can just note it down. From here now, you have written this.
Yeah, I wrote that, sir.
This thing.
Yeah, the question of right.
Just write this. In the next class, we will discuss the Wheatstone
Yes,
bridge.
sir.
Wheatstone bridge. So Harsh, you should remember this thing, short circuit thing.
Yes, sir.
If you connect the resistance with a wiring like this, then there is no existence of resistance. There will be no resistance there. Resistance is there, but we can replace that resistance with a single wire.
Single wire, yes, sir.
Yeah.